On August 12, 2026, daylight will vanish. A high-speed shadow will rush across the northern hemisphere, turning afternoon into night. The moon is exactly 400 times smaller than the sun and sits 400 times closer to Earth, perfectly blocking the solar disk. This alignment creates a 300-mile wide shadow dropping from the Arctic, sweeping across Greenland, Iceland, and straight through Spain. If you are watching from the United States, your view will be completely different. Up in Anchorage, Alaska, observers will only see about 28% of the sun covered by the moon. Move across the country to the East Coast, and the vantage point is even weaker. In Boston, the coverage maxes out at 16%. For millions of Americans looking through protective solar glasses, the 2026 eclipse will look exactly like this, a small, bright crescent against the dark. But NASA isn't settling for the partial home view. Inside Mission Control, flight teams are preparing to chase the absolute darkness. While most of the country watches a partial eclipse, scientists are launching an airborne race against the clock to capture a few fleeting minutes of totality before it slips away. The vehicles for this pursuit are NASA's WB-57 research jets, designed to operate up in the stratosphere at 50,000 feet. Pilots will fly these jets at 460 miles per hour in the exact direction of the moving shadow. By racing along the eclipse path, they can manually extend the duration of totality. The goal of this high-speed pursuit is to get a completely unobstructed, prolonged look at the sun's outer atmosphere, known as the corona. This chart maps the temperatures across the sun's layers, highlighting the coronal heating problem. The star's actual surface is extremely hot, but as you move out into the corona, the temperature inexplicably spikes into the millions of degrees. To solve this thermal paradox, scientists need data. The extra minutes these pilots squeeze out of the eclipse provide the exact time window needed to measure the corona's physics. Catching the shadow from the stratosphere is the only way to hold the solar window open long enough to observe an anomaly that defies our basic understanding of heat. Back down on the ground, the rugged landscape of Iceland is serving as the launching pad for a totally different experiment. Just minutes before the shadow hits, research teams will release 80 highly sensitive scientific balloons into the sky. This cross-section shows the Earth's boundary layer, the lowest part of our atmosphere. When the localized darkness of the eclipse hits, it causes the air temperature to plummet instantly. The atmosphere responds to this rapid cooling with chaotic turbulence, essentially tricked into behaving as if the sun has set in the middle of the afternoon. By combining the balloon data from the ground with the jet feeds from the stratosphere, NASA turns a brief celestial shadow into a massive temporary laboratory. By the time the shadow sweeps down over the historic coastal towns of Spain, it will be reaching the final stage of its journey. Observers here will witness a sunset totality. The completely eclipsed, blackened sun will vanish precisely as it touches the horizon line. Because the sun is sitting at such an extreme low angle, the shadow casts a 360-degree twilight effect, enveloping the viewers from all sides. The totality ends when the moon slips just enough to let a beam of sunlight through, creating a blinding flash known as the diamond ring. This climax in Europe is the exact same event casting that 16% crescent over Boston, showing how drastically our location on Earth shapes our cosmic perspective. Humanity has gathered to witness these perfect solar alignments for thousands of years, recording the sudden cosmic darkness with absolute awe. This orbital model maps a physical reality. The moon is slowly drifting away from Earth at 3.8 centimeters every year. As that orbit expands, the moon appears slightly smaller in our sky. Eventually, it will be too distant to cover the solar disk perfectly. While NASA fights to gain just a few extra minutes of darkness today, we are on a cosmic timeline where total eclipses will eventually end completely. The sliver of a crescent sun visible from a backyard in America is a reminder of our place on that exact timeline. Whether you're tracking NASA's high-altitude jets or watching a partial shadow from your porch, you are witnessing a temporary era of perfectly aligned geometry, an era that is slowly fading to light.